Okay, so as we were saying, so we are dealing with the following theorems. I call them the line from the center theorems.
Yes.
So we have a line which is going to be drawn from the center to a midpoint of a chord. Now, what is very important is to be able to take the following statement and then draw a rough sketch of it. So a line from the center of a circle to the midpoint of a chord. Now, how does a rough sketch of that thing look like? So if I were to draw a rough sketch of this thing, it's going to look something like this. Let me just, okay. So if I have a line from the center to a midpoint of a chord, so I need to have a chord. This is just a rough sketch. I'm not going to be drawing it to scale. So I have a chord because they say I need to have a line from the center to a chord. So you need a chord. Now, if we can just recap, we said what was a chord?
It was a line joining from one end of a circumference to the other.
So we have a line drawn from one end of the circumference to the other end of the what of the circumference. And then I can draw a line from the center now. That's very important. I'm going to draw a line from the center to the midpoint of a chord. Now, how does this thing look graphically? So graphically, how would I see it? I will see it by the following. It's going to have that this is going to be equaling to this. I don't have to measure them. So I'm just taking the statement that is written here, and then I am just drawing it, a rough sketch of it. So it's a line drawn from the center to the midpoint of a chord. So the diagram will look something like this. So it's a line from the center to the midpoint of the chord. Now, if they include something like this on your diagram, then it's a line from the center to the midpoint of the chord. That's the first one. Eh? And then we also have another statement. We should be able to take the following statement. So this one here, you have a line drawn from the center of the circle perpendicular to a chord. Now, how does that look like? So you have a line, so you have a chord, and then you have a line from the center to the chord. Now, where these two meet, they are going to form a 90-degree angle. Remember, today we're not proving the theorem. We are just going to be using the application of this theorem. So if you ask me, if I see something like this, I'm going to say this is the line from the center to the midpoint. So I'll call this one line from center to midpoint of a chord. And then if you ask me if I see a diagram like this one, I'm going to call it, it's a line from center, copying it from here. Ne? So you have the following as accepted reason. So I have line from the center perpendicular to a chord. I have a line from center to the midpoint of the chord. Now, it's very important that you are able to visualize that. Like, you should be able to visualize that. What do they mean when they say this? So if we move on.
Yes.
We have here a line from center. And then this is going to be perpendicular to our chord. Now, that's the first part. We should be able to look at the diagram and then say this is what is given. And then at the same time, we should be able to take the statement and then draw it. If they give me a line from the center perpendicular to a chord, I should be able to draw this. And then I should be able to draw a line from the center to a midpoint of a chord. Yeah? Now, what is the other thing that we should be able to do? The other thing that you should be able to do is that I should be able to look at the following diagram. Now, we have some few diagrams that we're going to work with. I should be able to look at the following diagram and say, what is given here? Can I say this in words? So here, if you look at the following, we have a line from the center. It goes to chord AC. Can you see that? Okay?
Yes.
Yeah, but when it gets to AC, what does it do? It has a 90-degree angle. So if you were to say this in words, you will say that you will have a line. This is the line OB. Line, it's a line from the center, and then this line is going to be perpendicular to the chord, which is chord AC, but I don't have to write what is the name of the chord. So we have line OP, which is going to be perpendicular to chord what? AC. So this is the following diagram. If I look at the following diagram, I'm saying it in weights. Ne? Now let's come back to this one. If you given the following diagram, how would you say this in weights then?
Is the line drawn from the center and to the midpoint of the
so
chord.
here we have a line from our center to the midpoint of the chord. Here you have line from the center perpendicular to a chord. Here you have the line from the center to the midpoint of the what? Of the chord. Now I'm just going to give you some few diagrams as we recap so that you can look at them and then tell us what are we given in each of those circles. So let's look at the following. In the following diagram, what will you say we are given here? Let's look at this one here.
That one is the line from the center to the midpoint of the chord.
So this one you are saying is the line from the center
to the
midpoint of the chord. Okay, let's look at this one here. What do you have here?
Line from the center to the midpoint.
So here again, you're saying we have the line from center to midpoint of the chord. Now, if we look at the following, let's look at this one here. Here, in the following diagram, what do you say? What do you think we have?
Is the line from the center perpendicular to the chord.
So here you have a line from center, and then it's perpendicular to the chord. Fortune, welcome. I can see we have Fortune and Happiness. But they didn't turn their mic on. Yeah, you can turn your mic on, Fortune and Happiness. Okay, so we have a line from the center perpendicular to a chord here. Okay, yes. I want us to go through this activity once more. Let's just look at the following here, and then you'll just tell me what is it that we have. If you look at the following, let's look at this one. What do you think we have on this diagram here?
Is the line drawn from the center and perpendicular to the chord.
Okay, this is line from center, and then this is perpendicular to the chord. Okay?
Yes.
Okay, then we can have, look at the following. Here, what do you think we have?
Is the line drawn from the center and is perpendicular to the chord.
The line drawn from the center perpendicular to the chord. Ne? And then yes. I think we've touched almost on all of them. Ne? So now what I want us to do is that, why is this thing important? Why do I want you to know this? Now, you will realize that theorem 1 and theorem 1a, they are not that complicated when we apply them. We're going to be using theorem of Pythagoras, but what we are going to have is the following dilemma. A complete diagram should look like this. It should have a line from the center, perpendicular to the chord, and then it should bisect the chord. But as you have seen with all the diagrams, you're going to be given one thing. If you look at the following diagram, what is missing such that this diagram is going to look like this one here?
The lines that are equal.
Yeah, the midpoint part. Ne? So
yes.
I'm going to add this thing here because I'm adding it. I'm the one who's adding it. I will have to tell them why am I adding it. So I will come and say, okay, here, This is going to be equaling to this one. It's true. Those two things are going to be equal. And then I will say AF is going to be equaling to what? To FB. Now, if they ask me why am I saying that, I am going to tell them that is because I have whatever was given in the beginning. So here you are given a line from the center perpendicular to a chord. Ne?
Yes.
So you're given a line from center. So you will write the above here. Now, if we look at the following here, what seems to be missing on this diagram here, such that it looks like this one?
It's that perpendicular right angle.
So we are missing this angle here. This angle should be 90 degree here. Yeah? So we'll come and put this 90 degree. And then when we put that 90 degree, we'll have to tell them why are we saying that. The reason why we are saying that is the reason that we have written here. So every time when we deal with these questions, we'll start by looking at the diagram and check what is given. And then after that, we'll add what is missing so that the diagram is complete. Yeah? So here we'll say, okay, here we can have angle ABO. So we will say angle ABO is going to be equaling to 90 degrees. When they ask us why are we saying that, we quote whatever we've written before. It's a line from the center to the midpoint of the what of the chord. So a line from the center to the midpoint of the chord, they say is going to be perpendicular to the chord. That's what the theorem states.
Yes.
Still good. Okay, let's come back to this one. Yeah. What is this diagram missing?
The sides that's supposed to be equal.
The sides are supposed to be equal. So we'll come and add that because it's not given. So we'll come and put this. This is going to be equaling to this. So in other words, you will say, okay, AB is going to be equaling to BC.
C.
And then what is going to be your reason? Your reason is that you have a line from the center perpendicular to the chord. Do you get how we're going with this? No?
Yeah, I see it.
You see it? No? Okay, do this one then, because you said you can write also. What seems to be missing on this diagram here?
Is the 90 degree.
It's the 90 degree. Okay. So you'll put the 90 degree. Before you work with this type of questions, you need to write whatever is missing. After writing what is missing, then you add. Why are you saying that? Ne? So if you put the 90 degree here, so you're going to come and put 90 degree. In other words, you're saying angle ACO is going to be equaling to 90 degrees. Why are you saying that?
Line from the center to the midpoint of a chord.
So it's line from the center to the midpoint of the what of the chord. So that's how we're going to be dealing with these questions here. And then I just want us to take one example. And then from there, you'll have your own activity. Ne? So let's look at the following. So we're going to go through this one together. And then you'll have your own activity. So how would you approach such a question? We're going to start by brainstorming then. They say here, whatever it's going to be written there on the statement, we'll try to highlight it on our diagram. So we encourage you to have colored pens when you're dealing with such questions. So for example, here, the first thing that they are saying is that we have in the diagram, we have O is the center. So we have our diagram, which has the center O. And then they say in the diagram, O is the center of circle ABD. So we have ABD. They're naming the points that are going to be at the circumference. And then point F is a point on a chord. So here is point F. And then AP is such that they say we have DOF, which is going to be perpendicular to AB. So there's a 90 degree angle then. And then the other thing that they're saying is that AB, do you see our AB? I will highlight it in red. AB is equaling to 8. That's what they're telling us. Our AB is equaling to 8, but it's equaling to FD. Now, I'll also highlight it in red because those two are equal. So from F to D, this is also 8. This one and this one are equal because both of them are equaling to what? To 8.
8.
Now, I haven't started doing the question. I'm just simply brainstorming here. And then they are telling me that OF is equaling to X. So from O to F, they're saying this here is going to be equaling to what? To X. Okay.
X.
Now, what are they looking for? They're saying I should determine the length of the radius. So I want to get the radius here. I want to know what is going to be this thing here, which is going to be our radius. Our radius, it's a line from the center to the circumference. It's not a line from the center to the chord. It's a line from the center and then it goes to the circumference. Okay, I want this. But while we are still on the same diagram, look at the following. I also have another line from the center to the circumference, which is OD. Can you see that?
Yes.
So you can say this line and this line are going to be equal.
Yes.
So in other words, I will say OB is equaling to OD. And then the reason why I'm saying these two are equal is because they are radius.
Yes.
So it's because they are radius. And then at the same time, now I want to write this side here in terms of X, because here's what I know. I know that from O to F and then from O to D, the length is going to be equaling to 8.
Yes.
So I will say, okay, if I want to get FD, the simplest way to get FD, it will be to write it as OF and
plus OD.
Plus OD. But I know what is FD. What is FD?
X.
So FD. Look at FD.
FD is 8.
What is FD?
8.
So it's 8 here. Yeah? And then
yes.
What is OF?
X.
This one is X plus OD. So I can get OD in terms of 8 and what? And X.
And X.
So if I take the X to this other side, it says I'm going to have 8 minus X, which is going to be equaling to what? To
OD.
We're still good then?
Yes.
Okay. And then from here onwards, I will come and say, instead of this being OD, I can write it as 8 minus X. And then the question that you might be asking yourself is, why am I going through all this trouble here? I want to use the following, right? Yes?
You say, oh, that's OB.
That's, yeah, this one is OP. OP and OT, remember, they are equal. Remember, OP and OT are equal because both of them are what? Are radius. You still good then?
Yes, okay. Yes.
Okay, but now, remember, we said there was something which is missing here. Let's put whatever is missing here. So we have a line drawn from the center perpendicular to a chord. Ne? Now, what is missing such that this thing here is complete? What's missing is that this is going to be equal to this. Ne?
Yes.
Now, why are we saying that? Remember, AF is going to be equaling to FB, which is going to be equaling to, because this whole thing here, remember we said this whole thing here, it's 8, ne?
Yes.
And then AF and FB, they are going to be equaling to what then?
To 8. To 4.
To 4, yeah? They're going to be equaling to 4. Why am I saying these two things are equal, by the way? In fact, we should have started there.
It's the line drawn from the center to the midpoint of a chord.
No, it's a line from the center to, what is here?
90 degrees.
Yeah, so it's line from the center perpendicular to a chord. So you have the line from the center perpendicular to a chord. So you're going to have line from center perpendicular to chord. So in other words, you know this one is 4 here. Ne? Now you have a right angle triangle. Look at the following now. You have a right angle triangle. And then if you have a right angle triangle, then you can use theorem of Pythagoras. So if I'm going to use the theorem of Pythagoras, I will say I have the following triangle. Let's take it out so that you will see it. So you have the following triangle, which looks like this. Here you have 4. Here you have x. And then here you have 8 minus x. And then here you have 90 degrees. Since you have 90 degrees here, then you can use the theorem of Pythagoras. Né?
Yes.
Okay. So let's do this. We're going to have, let's put it here. We're going to have OB all squared. So we have OB all squared
Equal to FB squared.
Yeah, so OB all squared is going to be equaling to OF all squared plus FB all squared. Now we know what is OB. Let's check what is OB.
It's 8 minus x.
So this is 8 minus x all squared equals to and then do we know what is OF? What is OF?
X.
So we'll come and put x here all squared plus, do we know what is FB?
It's 4.
So our FB is going to be equaling to 4 all squared. Now, if you see a squared, we can't raise the power to the first power because of this negative. You remember that? So what we're going to do is to expand this bracket. If we expand this bracket, we're going to have 8 minus x. Here we're also going to have 8 minus x, which is going to be equaling to x squared. Plus, if we type 4 all squared, is going to give us 16. Now, if I say 8 multiplied by 8 is going to give us what?
64.
And then if we say this one multiplied by this one is going to give us minus 8x.
8.
This one multiplied by this one, it gives us minus 8x.
8.
And then this one multiplied by this one is going to give us plus x squared. And then we have x squared plus 16. And then now we're going to group like terms. As you can see, we have x squared, we also have x squared. No?
Yes.
So we're going to take everything to this other side. Now, if I take this x squared to this other side, it's positive. If it comes to this side, it's going to become what?
Negative.
So I have this one and this one, which are going to cancel each other out. And then these two are also like terms. If I add them, I'm going to get what?
Minus 16.
Minus 16x. Now I'm going to take 64 to this other side. I have 16 minus 64. What is going to be 16 minus 64?
48.
So here you have minus 48, not 48.
Yes.
Minus 48. And then you divide both sides by minus 16. You divide both sides by minus 16. And then what do we get as our x value?
3.
Our x is going to be equal to what? To 3 centimeters. But now we're not looking for x, we're looking for the radius.
Mm.
Let's come and check what is our radius. Yeah?
It's 8, not 3. My mistake.
If you say, when you say minus 48 divided by 16.
16. All right. No, it's fine.
It's fine. Okay. So it's minus 16 here. Ne? Okay. And then what did you get as your answer? You got minus 3x. Ne?
Yes.
Okay. Now, we are looking for the radius. The question was saying, look for the radius. What is our radius? Our radius, it can either be OB or it can be OD. Ne? And then we said our radius OD in terms of x is going to be 8. It's 8 minus x. Can you see that? But we know what is x. What is x now?
X is 3.
It's 3. Then it means our OD is going to be equaling to 8 minus 3, meaning our radius is going to be what? To be 5 centimeters.
5 centimeters.
Yes. Okay, but now before we go to your activity, I just want to recap here. How do we approach this question? I think It is very important to understand what we spoke about. So you're going to be given, and then you're going to brainstorm.
Yes.
So here, the first thing that we're supposed to do here, so that at least we're going to get the first mark. If we're given the diagram, the first thing that we want to do here in our diagram is to add whatever is missing so that the diagram is complete. We can't solve the diagram if it's not complete. Before we even read the statement, we look at the following diagram. When you look at the following diagram, you say, what is missing here? What is missing? Okay, let's start it this way then, Sepis. What are you given here in this diagram? When you look at the following diagram, we spoke about that. What is it that we are given here?
Given that the line, the 90 degrees.
So it's a line from the center perpendicular to the chord. No? So come and write that. Say, in the following diagram, you are given a line from center perpendicular to the chord. Now, what is missing here? We are going to add that, whatever is missing, and then we're going to use this. We're going to be using this reasoning. What is missing again on our diagram such that it looks like this diagram? Remember the diagram, the ultimate goal of the diagram is to look like this. No?
Yes.
So what is missing here?
The equal sides.
The equal side. So you will come and write the equal sides here. You will say, okay, but now AF is going to be equaling to what? To FB. And then the reason is because whatever is given. So you have a line from the center, which is going to be what? To be perpendicular to the chord. And then from there onwards, after you have done this, then you can go and read your statement. On your statement, they say you have a diagram with center O, and then you have point F on the chord AB such that the two are perpendicular. And then they say that AB from A to B is equaling to F to D. Né?
Yes.
And then they are saying those things are equaling to 8. It means this one here is 8 centimeter. And then this one here is also going to be what? 8 centimeter. Now, based on what you have written here, if they're saying this thing here is 8, you can come and tell them, but it means that one of this thing here is going to be what? To be 4 centimeter. Then I think you can come and try to do the following activity. Yeah, I will come and do the following activity. And then I think when you are done, we'll then talk.
Yes.